Ladder logic. You should probably know it. Hello, welcome to Chaos and Controls, a show where we talk about modern devices, technologies, and techniques for automating your home, business, or life. I'm your host, the Automation Doctor. So, first and foremost, for the 3.5 of you that actually watch these videos, I apologize. I know I'm running just a little bit late. Had some drama with a refrigerator that we'll probably actually have a chance to talk about on this channel. But never mind that, right now I think we should talk a little bit about ladder logic and where you might find it. Now, ladder logic is probably the most common form of programming that you are going to find inside of PLCs. And it actually derives from old school relay logic. And the reason that it has persisted is because relay logic was something that the technicians understood and could do in the field. And so when we started going digital, the world was looking for something that we could translate into something the technicians recognized without having to teach another programming language. And so in a relay circuit, if I have a classic start-stop circuit, it looks something like this. And fun fact, this symbol is usually denoted as an almost circle with a line in the middle, and the reason for the line in the middle is old school plotters, not printers, plotters, could not actually draw a full circle. Modern stuff, you'll find a mix. Some people throw homage back to the plotter days, some people just make it a circle. We'll go ahead and fill these in as stop, start. This is going to be M1, and this is going to be M1 underscore status. So this is the classic relay for a start-stop circuit, and anybody who can explain this in ladder logic, I am willing to say, has a reasonable understanding of how relay logic works. And so we're going to dive into this just a little bit and talk about, typically I've got my power rail here and my ground rail here, and I've stated before that most things in industrial controls run off of 24 volts, and so what you can imagine is that we are trying to get 24 volts to, this is typically a coil on a relay, and if we can energize that coil on the relay, we will start the motor. And so the way to read this statement is that 24 volts gets to my motor if I have not pressed the stop button and I have pressed the start button, or I have the status bit. In other words, the motor is already running. So in other words, I could say M1 is equal to not stop and start or M1 status. Said another way, I have stop, start, and status. And if I have not stop, and either, I have stop not and start or status, I get M1. And so this all ties back into what we've been discussing about how there are multiple ways to show the same kind of logic in, multiple methods. Lastly, maybe we should draw the truth table for this, where I have stop, start, slide that over just a bit, status, and my motor output, ever so slightly more. Please bear with me. I know I have a true engineer's handwriting. We'll get some lines going in here so we can go fill this out. It's a random shot in the dark on lines. Hopefully I got it. Every other one. Oh, I think I got too many. Every second one. And every fourth one. And so, obviously, if I have a stop signal, I am not going to run the motor. If we're stopped, not running, and I don't hit start, we're not going to have the motor. If I'm stopped, don't hit start, but we're already running, we'll keep it running. If we're stopped, I press start and I'm not pressing start, we'll turn it on. And if I press start while it's already running, provided I'm not also holding the stop button, sure, we'll let it start. All of these are the same information in a different way. That's about all I have for you today. We're going to go a little bit deeper into this particular circuit and eventually work our way up to the HVAC example that I hinted at in another video. But in any case, that's about all I have for you today. You all have a good one, and I will catch you next time.